Hello everyone, welcome to ICP-DAS's webinar. I am Alla from the International Sales and Marketing team, and it's great to have you here. Thank you for your feedback from our recent webinar survey. It is helping us shape future sessions around the topics that matter most to you. In future webinars, we will dive into the topics you highlighted. Before we begin today's webinar, I will first like to address the questions you left during our last session. The first question: can the RFU 433 be used for crane automation? Answer: yes, it can. We have a case study on this topic available on our blog page, so please be sure to check it out. The second question: what is the maximum transmission distance for the RFU? 500 meters in non-line of sight? Answer: the maximum distance depends on the type of obstacle. If there are significant barriers, you might want to consider using a Zigbee solution, as it supports mesh networking, allowing the signal to pass through other Zigbee nodes to bypass the obstacles. As we know, low-frequency signals typically experience less signal loss when passing through obstacles compared to high-frequency signals. However, different clients may have specific requirements for different frequency bands. To accommodate this, ICP-DAS offers wireless products in various bands. If you have the flexibility to choose, we recommend the RFU 433. Here is the radio wireless system configuration. The radio signaling is simple and supports only a start type topology. To extend the communication distance, we provide firmware that supports one-hop networking, which only slightly increases the routing time. However, we still recommend adding an MDC 711 to boost the communication speed and connect to Ethernet. Of course, if clients have a limited budget, they can opt for a TGW 700 or TDS 700 as an alternative. Here is a Zigbee wireless system configuration. Zigbee signaling supporting both mesh and multi-hop networking, allowing it to work not only in a start type topology, but also in a line type topology. However, supporting mesh networking requires additional routing time to optimize performance. ICP-DAS typically adds an MDC 711 to boost communication speed and connect to Ethernet, allowing the host PC to operate more smoothly. In this real case scenario shown in the picture, the distance between two rooms is less than 20 meters. But the 2.4 GHz signal cannot pass through multiple metal cabinets. Therefore, ICP-DAS added an additional Zigbee module as a repeater, allowing the wireless signal to make a V-turn and maintain connectivity. And the final, third question: can the PMC 5231 generate a harmonic report for energy audits? Answer: currently, we are upgrading the power meter firmware to support three-phase total harmonic distortion (THD) parameters for voltage and current. Once the firmware is complete, we will consider adding THD data to the PMC 5231 web's interface and reporting capabilities. Additionally, I would also like to mention that there will be no live Q&A session after today's webinar. Instead, our colleague Louis will be available in the Zoom chat room to answer your question during the presentation. If you have any additional questions afterward, please leave them in our questionnaire, and we will address them in the next webinar. Now, let's begin our webinar. In today's session, we will explore how system integration can greatly improve efficiency in food production, energy management, and overall manufacturing. Let's dive into how ICP DAS's solutions can streamline your operations and help your businesses grow. Recognizing the importance of system integration is the first step to ensuring an organization has accurate, consistent, and accessible data, paving the way for better business insights and smarter decision-making. What is system integration? It combines information from various sources into a single, accurate view. By unifying data from multiple databases, apps, and platforms, it gives organizations a complete picture of operations, leading to better insights and enhanced customer experience. Why it is important? System integration simplifies access to information, providing businesses with a real-time overview that improves efficiency. Without it, gathering insights can be slow and often involves manual work across different systems. System integration offers significant benefits, including reduced downtime and increased efficiency. By connecting separate systems into a unified platform, integration allows for reduced downtime. With real-time monitoring and centralized control, issues are detected early, minimizing disruptions and keeping operations running smoothly. Enhanced efficiency. Automation of data collection and streamlined workflows eliminate manual tasks, allowing teams to focus on higher value activities. Improved data accuracy. Integrating data from multiple sources ensures a consistent, reliable view, reducing errors and improving decision-making. Cost savings. Eliminating duplicate processes and reducing manual labor lowers operational costs. Overall, system integration empowers businesses to operate more effectively, maximize uptime, and respond faster to changing conditions. Next, I will walk you through 4 case studies where ICP DAS has helped customers improve their production efficiency and data management. Let's start with the first case, streamlining production records at the milk powder factory. This milk powder factory struggled with scattered data, making it difficult to manage production efficiently and ensure food safety. Their separate weighing and temperature and humidity systems lacked integration, complicating product traceability and issue resolution. To improve oversight and enhance food safety, the factory needed a unified system integration solution to centralize quality control and production monitoring. The main challenges included scattered data. Information from machines wasn't integrated, making it hard to get a clear picture of the production process. Lack of traceability. Without a centralized monitoring system, operations were slow and inefficient. Quality control issues. Without proper monitoring, maintaining product quality was a difficult task. To solve these problems, they turned to data integration. The solution involved 4 major systems: powder inspection and weight system monitoring, oil tank overflow prevention monitoring, factory temperature and humidity monitoring, computer room equipment and environmental monitoring. ICP DAS's products connected the factory's original devices to the network, Ethernet, allowing the SCADA system to access real-time data from each of these systems. The weighing control system plays a vital role in monitoring the output weight of milk powder and equipment utilization rates. The production data from the PLC was sent to the PDS-734 programmable serial to Ethernet device server, allowing the SCADA system to access the data. The PDS-734 programmable serial to Ethernet device server connects RS-232, 422, 485 devices to an Ethernet network. Its virtual COM driver utility turns the built-in COM ports into standard PC COM ports with protocol independence and high flexibility. The PDS-734 supports various network applications. In this case, it transmitted data from the weighing system to the control center by converting RS-422 signals. To monitor oil tank levels, the factory installed sensors that transmitted data by Ethernet to the VICE7WA44 I/O module. This information was then relayed to the SCADA system, enabling operators to track oil levels in real time. The system helped prevent overflows, ensured efficient oil usage, and was built to comply with regulations. Also, during a typhoon, maintenance personnel no longer need to visit the factory for status inspections. Instead, they can monitor the overflow status remotely and take immediate action if necessary. The VICE7144 is an intelligent I/O module featuring 8 digital inputs and 8 digital outputs with Modbus TCP I/O capabilities, enabling seamless integration with external hosts like PLCs and SCADA systems. It also supports edge computing with a no-code interface. Its if-then-else function ensures that necessary actions are taken even if the connection between the VICE7144 and the control center is lost, maintaining continuous operation and safety. With its built-in web server, the VICE7144 can operate autonomously without the need for additional support from external hosts. For environmental monitoring, the factory installed temperature and humidity sensors across 4 floors to ensure optimal conditions for production. These sensors continuously track real-time data, helping operators maintain the required environmental standards. All temperature and humidity data was centralized using the MDC711 Modbus data concentrator, simplifying the management of environmental conditions and ensuring consistent production quality. The MDC711 is a powerful Modbus data concentrator that optimizes command efficiency and system performance. It expands serial ports and consolidates Modbus tables, centralizing field Modbus RTU data to reduce host read-write times. Additionally, the MDC711 can integrate data from various temperature and humidity sensors located on different floors, accelerating data collection for the control center. With a built-in web server for quick setup, streamlined CSV import-export configuration, and the web-based diagnostic page, the MDC711 simplifies both maintenance and troubleshooting of Modbus RTU communication issues. In the computer room, the UPAC7186EX controller collaborates with DL10 sensors to monitor temperature and humidity, triggering alerts for any fluctuations to maintain a safe and stable environment. Additionally, the ACS11MF access control system accurately logs staff access and can be seamlessly integrated into production lines to keep track of the employees responsible for each batch. The UPAC7186EX series is a compact, High Performance Programmable Automation Controller, PAC, designed for rapid deployment and stable operations in industrial settings. Equipped with the Mini OS 7 system, it boasts a fast boot time of under a second and immunity to most viruses. It provides robust development support with tools for both C programming and soft graph, making it adaptable for various applications. Enhanced with multi-communication operations and advanced stability features, the UPAC 7186EX is ideal for developers seeking a reliable, multifunctional controller for complex control systems. This integration led to several key improvements for the milk powder factory. System integration. By centralizing data from various sources, such as powder inspection, oil tank levels, and environmental parameters, the factory streamlined its monitoring and enabled real-time analysis. This integration improved data accessibility, minimized production errors, and gave management a clearer view of overall factory performance. Food traceability. The new system provided accurate logging and storage of all production data, ensuring full traceability of ingredients and processes. This allowed the factory to easily track each batch, meeting stringent food safety standards and simplifying regulatory reporting. Enhanced food safety. Real-time monitoring and automatic data recording of critical parameters enhance food safety by ensuring consistent product quality. The system's ability to generate detailed reports for regulatory bodies reduced the risk of compliance issues, fines, or recalls. Overall, these improvements significantly boosted operational efficiency, product quality, and regulatory compliance, allowing the factory to better meet production goals and customer demands while ensuring food safety. The next case is about optimizing production process monitoring at a steam bun factory. This steam bun manufacturer had a few key issues. First, only a small number of employees controlled production, and records were handwritten, leading to mistakes. Second, without accurate data, monitoring machine performance and yield was tough. Finally, it was hard to track defective batches, causing large-scale product losses. Specifically, the challenges included manual record keeping. Production records were prone to errors, making it difficult to accurately track performance. Limited oversight. With only a few employees overseeing the process, understanding raw material selection and standard procedures was a challenge. Traceability issues. Identifying affected batches during production issues was difficult, leading to costly recalls or disposal. To tackle these challenges, the factory set 3 goals. Short-term, to collect production data and establish a visualized graphical control system that provides search functionality for detailed individual process production information. Mid-term, to establish a product production traceability mechanism that allows for real-time monitoring and analysis of equipment usage and performance metrics. Long-term, to implement intelligent production scheduling that predicts and analyzes production line status, correlates raw material inputs with processes, enables predictive maintenance, and optimizes process parameters through big data analysis. To avoid shutting down the operating machines, wireless modules were selected for their ability to integrate seamlessly without disrupting production. This decision supported the factory's ambitious goal of visualized production control, traceability, and ultimately smart manufacturing. ICP thus implemented a comprehensive wireless monitoring system tailored to the factory's complex environment. Let's explore how each part of this solution played an essential role in enhancing the factory's operations. Wireless system using sub-1 GHz technology. The factory's dynamic environment, including frequent machinery movement and high humidity levels across the 3 fermentation zones, pose significant challenges for reliable data transmission. ICP thus addressed these challenges by deploying a sub-1 GHz wireless communication system. This low-frequency technology provided superior penetration through walls and obstructions, ensuring stable and long-range communication without interference from other wireless devices in a factory. It enables seamless monitoring of critical production parameters, regardless of physical barriers or environmental conditions. The RFU433 is a reliable wireless communication module that converts RS-232/485 signals for long-range transmission, reaching distance up to 500 meters in the 433 MHz frequency band, designed for easy setup and robust performance in industrial environments. It includes DIP switch configuration for quick network organization, supporting 16 RF channels and 8 group IDs. Operating in the sub-G frequency range, the RFU433 avoids interference from commonly congested 2.4 GHz and 5 GHz bands, making it ideal for factory applications running stable wireless RS-232/485 communication. The DL100TM485S remote temperature and humidity data logger monitors temperatures from -20 to +60 degrees Celsius and humidity from 0 to 100%. It contains LCD display to show a variety of data such as temperature, humidity, dew point, and module ID. With storage for 4088 records, it provides easy access to historical data for compliance and analysis. Its RS-485 Modbus interface enables smooth integration with SCADA systems for real-time monitoring, and the IP65 front panel protects it from dust and moisture in the factory environment. Programmable Automation Controller Pack with Isograph. A key component of the system was the pack equipped with Isograph, a powerful and flexible control platform. The pack controls real-time data from multiple sources, including environmental sensors monitoring temperature, humidity, and CO2 levels in the fermentation zones. It also allowed for remote configuration of the system, making it easy for operators to adjust settings or fine-tune process parameters as needed. More importantly, the pack was programmed to automatically trigger alarms when environmental conditions deviated from the optimal range, helping operators intervene before any damage occurred to the product. The UPack 7186EG serial Ethernet pack collects serial data from various sensors, enabling comprehensive monitoring of production parameters. Equipped with the Mini OS 7 system, it features a fast boot time of under a second. It offers robust development support with embedded Isograph soft logic and serves as a gateway to integrate diverse data sources. Operating efficiently with low power consumption, its compact palm-sized design allows for easy installation in limited spaces. Graphical software for user-friendly monitoring and analysis. To help operators easily understand the vast amount of data generated by the monitoring system, ICP DAS integrated the graphical software interface, eLogger. This user-friendly platform displays real-time data in clear visual formats like graphs and charts, allowing operators to quickly track production conditions, spot trends, and identify anomalies. This real-time visualization helps the factory improve machine utilization rates and reduce manual recording errors. The table outlines the key features of eLogger and Aviva Edge, comparing their capabilities for industrial and IoT applications. In summary, eLogger is ideal for smaller enterprises due to its lightweight design, straightforward setup, and compatibility with ICP DAS devices. Its lower cost and essential features for real-time monitoring, basic data logging, and remote access make it highly accessible without the complexity of a full SCADA system. Small to medium IoT projects and simpler industrial automation tasks can benefit from eLogger's functionality without the need for advanced scripting or high customization, offering an efficient and budget-friendly solution for businesses with focused monitoring needs. ICP DAS's solution has transformed the factory's production by improving real-time visibility into machine performance, enhancing resource allocation, and reducing waste through robust product traceability. This system enables early detection of defective batches, improving quality and minimizing loss. Predictive maintenance and optimized scheduling have also reduced downtime and boosted efficiency. Future integration with AI will enable advanced capabilities, such as automated fermentation monitoring. Moving on to the third case, energy monitoring and predictive maintenance at the palm oil plant in Thailand. This company focused on palm oil production but faced challenges with power management and equipment maintenance. Operators had difficulty monitoring palm kernel seed feeding, which led to spikes in power consumption and increased wear on the machines. The harsh tropical climate added to the problem, making it tough to maintain productivity. The main challenges were related to the manual monitoring of palm kernel seeds, which led to inefficiencies as operators struggled to maintain optimal feeding conditions for the oil milling machines. Overfeeding resulted in surges in power consumption, potentially causing equipment shutdowns and increasing maintenance costs. Additionally, the tropical climate added further difficulties, with workers facing heat, fatigue, and safety concerns, all of which negatively impact productivity and product quality. ICP DAS introduced a solution that focused on cost savings, reduced operational costs through improved efficiency, energy savings, optimized power consumption to decrease utility expenses, electrical safety, enhanced workplace safety to minimizing risk associated with equipment failure, predictive maintenance, implement a system for proactive maintenance scheduling to reduce downtime and maintenance costs. ICP DAS installed PM3133360P smart meters and PMC5231M power concentrator to monitor the energy consumption of the facility's oil expellers. The smart meters provided accurate, real-time power usage data, helping to detect performance fluctuations and inefficiencies. This data was continuously sent to the SCADA system, and displayed in an easy-to-use interface, allowing operators to monitor performance instantly and analyze energy usage. With this setup, operators could quickly spot wear in the oil expellers and schedule maintenance to prevent breakdowns. The PMC5231M power meter concentrator was installed to track whether oil expellers are continuously running, particularly during night shifts. The PMC5231 detects and logs power fluctuations, helping identify when staff might have pause feeding processes. Real-time alerts notify supervisors of low power levels, ensuring continuous operation and 24/7 accountability. By logging power data, the PMC5231 enables managers to analyze shifts, optimize processes, and keep expellers active, reducing downtime and maximizing production efficiency. The PM3133360P Smart Power Meter provides reliable energy consumption readings for oil expeller motors, collecting detailed power data from the voltage and current sensing wires of multiple on-site oil expellers. It connects seamlessly to the PMC5231M power meter concentrator via Modbus RTU, designed for low voltage circuits up to 500 volts. It offers accuracy better than 0.5%. The meter is easy to set up and maintain, with two built-in relays for controlling sound and light alarms. The new system brought significant improvements to the factory's operations. Production capacity increased by 28% annually, thanks to optimized monitoring that allowed for better management of the oil expelling process. Real-time data insights enable quick adjustments for optimal efficiency. The SCADA system graphical interface provided data visualization, helping operators make faster decisions and spot trends. Timely alarms notifications allowed supervisors to address issues immediately, preventing escalation. Predictive maintenance reduced mechanical failures by monitoring equipment health, leading to fewer breakdowns and lower maintenance costs. Overall, the factory became more reliable, efficient, and positioned for sustained growth. Lastly, let's look at our final case study, factory upgrade and networking project for passive components production. This factory specializes in the production of passive components, such as resistors and capacitors, which are essential for various industries, including automotive and electronics. Despite their expertise, they face several challenges that hindered their operational efficiency and product quality. The challenges were related to manual inspections. The reliance on manual inspections created bottlenecks, slowing down production and increasing the likelihood of human error. Defective components occasionally went unnoticed, leading to costly recalls. Delayed problem solving. Without an automated monitoring system, operators struggle to identify and address issues in real time. This lack of responsiveness resulted in increased waste and operational disruptions. Maintaining quality standards. Upholding strict quality standards proved difficult due to inconsistencies in inspections. This jeopardized their ability to meet industry regulations and customer expectations, putting their competitive edge at risk. To address these challenges, ICP-DAS implemented a monitoring solution with M7026G multifunction I/O modules and M7018RG thermocouple input modules to gather essential machine data like temperature and operational status. The MDC700 series Modbus data concentrator aggregates this data, enabling seamless communication with Aviva Edge software for effective monitoring. Aviva Edge helps monitor 120 machines using 151 M7026G and 23 M7018RG modules connected through 10 MDC714 data concentrators, enhancing data collection efficiency and ensuring continuous operations, even during failures. In this application, Aviva Edge provides data display, storage, management, and statistical analysis. It calculates upper and lower limits based on machine data and generates trend charts. Users can create overlay charts to compare data from each field machine and calculate temperature differences. This enables Aviva Edge to detect abnormal machine behavior in real time and trigger alarms in the event of anomalies. The M7018RG 8-channel thermocouple input module supports multiple input types, including current, voltage, and thermocouples, offering multi-purpose measurement capabilities. It detects disconnections in any thermocouple channel, enabling personnel to adjust equipment issue promptly. The module collects temperature data from heating rods, ensuring accurate monitoring and helping prevent production waste caused by malfunctions. Additionally, it facilitates preventive maintenance, identifying potential issues before they impact production and minimizing raw material waste. The M7026G multifunction module receives energy data from machines and records both analog and digital information for comprehensive monitoring. It monitors critical parameters, including material filling, door openings, operating states, standby status, and anomalies, enabling real-time monitoring of machine performance and helping to identify and address issues promptly for improved efficiency. Additionally, it transmits collected data to the MDC714 Modbus data concentrator for aggregation and further processing. The MDC714 Modbus data concentrator enhances Modbus commands efficiency by expanding serial ports capacity and consolidating field Modbus RTU module data into the MDC module, reducing host read write times and improving system performance. It offers easy setup and maintenance with a built-in web server, allowing configuration editing via CSV files and supporting import-export functionality. Additionally, the web diagnostic page simplifies troubleshooting of Modbus RTU communication issues, while the module eliminates data silos and enables easy data sharing. The Vice Edge controller transforms equipment networking by allowing real-time data monitoring and analysis right on site, eliminating the need for cloud support. This reduces latency and bandwidth costs and ensures smooth operation during network outages. It sends emergency alerts to maintain system stability and has a built-in data logger that saves information during outages, automatically sending it once the connection is back. In this application, the Vice 2241M IoT Edge controller manages real-time computing and alerts, keeping maintenance teams updated on machine status and performance. The Vice 2241M offers web browser-based real-time monitoring and data logging, with no programming required. It features built-in timers, schedules, and if-then-else notifications via SMS, Line, WeChat, Facebook, and email. Designed for seamless integration with edge computing, it supports flexible I/O, easily connecting XV boards, TCON, and Modbus RTU TCP slave devices, with comprehensive protocol support, including Modbus TCP, RTU, SMNP, MQTT, and FTP. It ensures compatibility with various devices and systems. Additionally, device 2241M is equipped with dual Ethernet ports, enhancing network connectivity and flexibility. The implemented solution achieves several key results. Data integration provided comprehensive visibility across the production line, enabling better decision-making. Operators benefited from organized remote supervision, allowing them to monitor machine performance and respond to alerts without being physically present, which significantly boosted efficiency. Enhanced data management ensures high quality in compliance with regulatory standards, helping maintain market competitiveness. Through ICP DAS's innovative solution, the customer established a robust data acquisition and transmission system. This advancement gives operations and maintenance teams remote access to essential data, supporting proactive management and operation of production processes. Additionally, immediate alarm notifications for any anomalies help maintenance smooth operations of the production line. The implementation of ICP DAS's innovative solutions in various industries has demonstrated how data integration and real-time monitoring can greatly enhance production efficiency and product quality. In the milk, powder, and steam band factories, effective monitoring of the production environment allows for data-driven decision-making, helping to overcome initial challenges and meet production goals. This optimization led to increased efficiency and reduced costs, highlighting how integrated technologies can elevate food production standards. Similarly, the smart energy monitoring solution for the palm oil mill addressed the client's issues with high-precision smart meters and introduced a comprehensive predictive maintenance strategy. This transformation significantly improved production efficiency, enhanced safety, and resulted in considerable cost savings, showcasing the impact of IIoT technology in modern manufacturing. Additionally, a robust data acquisition and transmission system implemented for a passive components manufacturer provided operations and maintenance staff with remote access to critical data. This proactive management, along with immediate alarm notifications for any anomalies, ensured smooth production line operations. Overall, these success stories reflect ICP DAS's commitment to using technology to drive operational excellence, optimize production processes, and boost the competitiveness of manufacturers across various industries. That concludes our webinar for today. I hope these case studies have provided you with valuable insights into how ICP DAS solutions can transform your operations. Please remember to scan the QR code and complete the questionnaire. Once you complete it, we will send you the presentation. Thank you for joining us today, and we look forward to seeing you in our next webinar.